is a really cool relationship that allows you algebraically to come up with the vertex form without actually having to do completing the square. Right? So, but bear in mind, and to repeat this over and over and over again for previous classes, I'm not going to name names or anything, but the directions dictate what method you have to use. If there's a multiple choice question that says, for example, write the equation in vertex form, and that's it, then you can do it any way you want. If there's a multiple choice question that says, write the equation in vertex form by completing the square, by using whatever technique, I could make up a technique, by using the can method, it does not matter because it's multiple choice. All I care about is the answer. If it's a free response question, it absolutely matters what method you use. All right, so understand that. It's very important. All right, in this case, it's saying explicitly to do it with completing the square, so that's what we must do. First step, subtract C. Okay. Remember, with yeah, there's two possible first steps. So you can subtract the C or you can divide by the A. It does not matter as long as you do it right. All right, so y minus c would be equal to ax squared plus bx. Then I would divide out the a from each term. Every single term gets divided by a. In which case we are looking at y over a minus c over a equals x squared. I'm going to write this as b over a times x. All right, I'm going to write it like that so that it's clear that the b over a is a coefficient of x. All right, if I write it as bx over a, it sometimes gets lost in the shuffle. What's what? I don't really want to deal with that. All right, I do need to complete the square. Now, when we complete the square, we take whatever the b value is. I'm putting that in quotes. Mistake. I make none.
B over A over 2. It's B over A over 2.
I'll happily answer your question in a second. So this part of the expression is your B, part of which is the A. So that's going to be included in our calculation. So we're looking at B over A. That's going to be divided by 2. And then we'll square it. All right?
B over A squared.
This part you might want to do just, take yourself back to middle school a little bit. Sometimes I do this just to get the thinking right. If I'm taking B over A and dividing it by 2, I might use the actual division symbol that we for some reason never use anymore, and divide it by 2 this way. Because when I look at it this way, I think keep, change, and flip. In which case, I get B over 2A. B over 2A is going to be squared, exactly. All right, so we're looking at B over 2A as a quantity squared, which ends up being equal to what?
3 over 4A squared.
Indeed it is. Very good. All right, so that's what's getting plugged into the gap. Very exciting. All right, so I'm popping in a B squared over 4A squared. But we know we can't just add to one side without adding to the other. And now I have to combine those two terms. Now, if they're numerical, you just put it in your calculator and call it a day. Here, I got to do some work. If I'm going to add 2 fractions, what do I need to have? Common denominator. What should my common denominator be?
A.
4A squared. All right. What do I have to multiply the first fraction by in order to make that A into a 4A squared? 4A. So I'll do it this way. All right. So I multiply an A by 4A. It's going to become 4A squared. I got to do that on the top also. All right. Top and bottom of the fraction. Now, you could show the extra work if you want, but it's kind of a nifty little workaround. when you put these two together, you get something that looks very familiar as part of the result. So we have y over a plus, what are those two things combined to?
B squared minus 4ac over 4a squared.
And the familiar part?
B squared minus 4ac.
B squared minus 4ac, which is?
The discriminant.
The discriminant. All right. So the discriminant works its way into this solution. That's pretty cool. All right. But it kind of makes sense that it would, because this is very similar to the approach that we used to solve for the roots of a quadratic, which gave us the quadratic formula, part of which was the discriminant. So the fact that it's here is not surprising. The right-hand side, to look at that expression and think, oh wow, I can factor this. That you might have to kind of use your imagination for, but it is factorable. Okay.
X plus b over 2a.
Exactamundo. All right, and the one thing to never lose sight of is, and this is a general rule of thumb, what is the question asking me? It's not asking this for the roots. If I was asking for the roots, I'd be looking to take a square root. It's asking me to put it in vertex form, which means I have to solve for y. So if I want to get y alone,
Multiply by a.
multiply by a? Sure, okay. I was going to do something else, but that works.
What were you going to do?
Now it's a secret. It's just like the a and c in the beginning. I could have moved this, or I could have multiplied by
Oh,
a
you're
first.
going to add by b squared minus 4ac.
I was going to subtract it off, yeah.
That's what I meant.
So y plus over what?
3a squared? 4a.
4a, yeah.
Why is it 4?
I'll show that in a sec.
Because it is.
Oh, hey, look at that. I still have it from period 3. It's just in a mess here. Let me get rid of all the extra fluff so we can see it. If you multiply a times b squared minus 4ac all over 4a squared, that big messy fraction.
It's like, it's 1 over a squared is what you're, like, obviously it's not, but like,
Right, but it,
part of it that matters is 1 over a squared, and then if it's 1 over a squared, because it's a over 1 and then 1 over a, so one of the a's cancels out.
right, we could rewrite it as a over a squared times b squared minus 4ac over 4. Just kind of take that a squared and move it over here, and then reduce this. We have a common a that can divide out. Divide top and bottom by a, you get a 1, you get an a. When you put it back together. That's one of the reasons why we spent so much time learning about factoring, because it's like weird relationships like this that come into play. And, you know, I mentioned this at the time, factoring is not a problem in and of itself all the time. It's going to work its way into everything else. So it kind of snuck its way into this one. You have a common factor so you can cancel. All right, if they're in different parts of a fraction or a product, one in the numerator, one in the denominator, if they're factors, you can divide them out and cancel them. All right. Final step,
Subtract.
subtract.
Oh, so like the discriminant over 4a is the c value.
Exactly, negative, but still.
Yeah.
Or it's the y value of your vertex.
The final answer?
That's your final answer. So in the next part, it asks us to state what the vertex would be, or axis of symmetry.
b over 2a. Negative b over 2a.
X would be equal to, it's always the opposite.
Negative b over 2a.
Exactly. The opposite of whatever is in the binomial. So in the binomial, it's b over 2a, so we negate that. The vertex is the h and k value put together.
B squared. Oh, and yeah, that's okay. Wait, why is it in parentheses?
Because I didn't want to actually distribute the negative. That negative sign belongs to each part of the numerator. I just didn't want to distribute it because then it wouldn't look like a discriminant anymore. So I wanted to still have a b squared minus 4ac. I didn't think negative b squared plus 4ac would look as nice. So that's just a choice for appearances. But what we get from this is a little bit of a shortcut, because you already know how to figure out the x value for an axis of symmetry vertex kind of deal. But let me just snag a problem. Cry. No.
And there's a comma.
So anyway, state the axis of symmetry in the vertex. I have a model for this. Negative b over 2a, so my vertex, negative 18 over 2 times negative 3. And then the y value be negative 18 squared minus 4 times negative 3 times 12. I'm just plugging and chugging away like a beast. Over 2, not worth thinking about. So 4 times negative 3. And so from those calculations you got, what do we say, 3 and 13?
I think it's 313.
What did you get? You got 15. All right, well, let's definitely do this. 18 squared minus 4 times negative 3 times 12 divided by negative 12. I got 39.
Did you use the negative?
I did. I used negatives and stuff, things.
Did I do something wrong?
I will look momentarily.
Okay.
So we have our vertex, our axis of symmetry, would correspond to x equals 3. All right, and our equation, like I said, just hang on to the a value. Y would be equal to negative 3 times x minus 3 squared plus 39. All right, now the super duper shortcut to this, one sec.